that's why the impetus for our company, Terran Space Technologies, to democratize space for all. But before I move on to my solution, let's take a peek into the future. Imagine you take a picture of a landscape and you're able to view it in 3D in real time. And you're able to tell various attributes such as the temperature, the radiation level. Imagine the applications it will have in, let's say, tourism industry or disaster management or even military. And that can be made possible by a fleet of satellites going around Earth at a particular position with respect to each other. But why has it not already been done? This is because these satellites lack maneuverability. But you might think, why so? That's because these satellites are really small. That's how it looks like. That's a 3U satellite which has one unit structure, cube-like structures, stacked on top of each other. And hence, they don't have enough space. And hence, they don't have enough space, or even the current solutions are not affordable or are only for the bigger satellites. And that is why we are to provide our solution, that is to 3D print micro thrusters that use water as propellant. 3D printing allows us to customize and also scale up by mass producing it. Customizability allows us to cater to the needs of the individual users while still scaling, while still reaping the scale of economies. The micro thruster is in fact just this small, which is our prototype, and hence we can fit it very nicely in any satellite. We are also planning to use water as propellant because it's highly abundant around the world, and it also allows us to get through the custom authorities without getting into problems. And this translates into cost benefits for our customers. Now, these are actually the applications that are made possible by our thrusters. As I already explained about formation flying for a fleet of satellites, our thrusters will allow them to maintain exact positions with respect to each other. Now, our thrusters also extend effective lifespan for our customers' satellites by more than 50%. That's by compensating for the drag because of the existing residual atmosphere even at high altitudes. We are able to resist that drag, we are able to compensate for that drag, and we can also allow the satellites to reach their desired position in the orbit much quicker, hence extending the effective lifespan. But you might think, why us? So that is because our thruster technology provides the most efficient power, it's most power efficient compared to any other technology out there. In fact, we do so at a much lower price as well. In the past, we have also talked to various companies, and these are our potential collaborators and customers who we are still in touch with to move our technology forward. We have also taken part in various hackathons, and we have also won the Airbus Innovation Award at Hack in Space 2018, which allowed us to bring our technology forward and to demonstrate it to various potential customers. In fact, our supervisor is himself the Director of Satellite Technology and Research Institute at NUS, and we can leverage his contacts to reach any customer around the world in the space industry. Now you might be thinking, what is the commercial viability? So let me tell you, the global space propulsion market is in fact exponentially increasing from 5.73 billion in 2018 to about 20.25 billion by 2027. And it also translates to the growth in Asia Pacific region, which is basically our beachhead market. Now, how do we plan to earn money? That's by selling the packages of these thrusters along with their auxiliary components and a plug-and-play software. We also plan to license our thrusters to various satellite part providers such as GomSpace and ClideSpace so that we can leverage on their existing customer base and their distribution channels as well to earn money through royalties as well. Now this small step into this space, literally and figuratively, will allow us to make our vision into a future that is to have a democratized space for all. Thank you, ladies and gentlemen, for your time. We are Terran Space Technologies.
It's quite interesting because CubeSats is actually, the market is actually expanding. The cost per payload delivery, I think it went down from a few $100,000 to now it's like $70,000, right, for the CubeSat. So in a low orbit environment, like with the microtrusters, I'm pretty sure your force would be also be not as much as, let's say, you use normal thrusters, right? Because so how would you compensate?
Oh, sorry. So our technology works by resistive heating. So you heat up the water, then it comes out as an exhaust. The thing is that one of the, if let's say in a on-Earth environment, the thrust that we've measured is actually the values that we've been quoting. When you actually bring up to say low Earth orbit when it's a vacuum, it's actually very.
So you use conductive heating, or
yeah, resistive heating. Resistive heating. Then to compensate for the drag, so this is the part that we're actually doing R&D right now, because in low Earth orbit there's quite a atmospheric effects. So there's a lot of other elements outside. But the good thing about technology is that it is not ion propulsion, which is the other devices.